Hey guys, here we are again. This is our lesson 7.5, parts of similar triangles for April 15. It should be a Wednesday. Hopefully my numbers and dates are good on that. So April 15th, Wednesday. Let's go after it. Hopefully we all got our quiz in and our review done. So should have had plenty of time to do that, hopefully. So today, parts of similar triangles. We're just going to read through some stuff. There's some definitions here, and we need to take a look at some notations in terms of what type of special segments are going to create these similarities. So, special segments of similar triangles. You learned in lesson 7.2 that the corresponding side lengths of similar polygons, such as triangles, are proportional. This concept can be extended to other segments in triangles. We are on page 501, lesson 7.5. Three theorems we're looking at right now. If two triangles are similar, the lengths of corresponding altitudes are proportional to the lengths of the corresponding sides. So as we look at these similar triangles with altitudes, right, from the vertex perpendicular to the opposite side, that's my altitude. Then we have, we look at our example, then we have example AD is proportionate to FJ, those are the two altitudes, and then AB, which is the hypotenuse, is going to be over FG, which is the other hypotenuse of that smaller triangle. So take a look at those relationships. You're going to have proportional sides. So the altitude is the key. Okay, the altitude on that is the key from the vertex perpendicular to the opposite side. Theorem 7.9. If two triangles are similar, the lengths of corresponding angle bisectors are proportional to the lengths of the corresponding sides. So we see that we're looking, in this instance, the special segment of the angle bisector. Okay, angle bisector. So we look at what the side lengths are. We have LP, which again is the angle bisector. We put the two angle bisectors as a ratio. LP over RT. Those are the two angle bisectors. And then we go over to, it's going to be equal to make it a proportion, LM over RS. So those are the corresponding sides of those two triangles. So again, we put the special segment as one ratio and whatever corresponding side you want to use on the other one. Last one looks like it's going to be the median. Okay? If two triangles are similar, the lengths of corresponding medians are proportional to the lengths of the corresponding sides. Again, we have CD over YZ. We're putting the medians as a ratio, right? Medians as a ratio. And then we look at AB over WX. Okay, so that's the total side of that. All right, total side of that opposite side. So we're looking at median, altitude, and angle bisector. Let's turn the page to 501 on this. And using special segments, all right, in example 1, we are going to look at those sides. And we are looking at triangle ABC and FDG, right? So when we have triangle ABC, okay, congruent to triangle FDG, okay, FDG, then we know that we have the sides are going to be similar, okay? Those sides are going to be similar, and so we have these sides also are going to be similar. So when we look at our two triangles, we have one triangle here, X, and we have 15 here. CPB. Okay, and this one is A. Okay, so AB we see is 15. Okay, AB is 15. And so we're looking at our angle bisector, right? We look at our angle bisector of AP, and our other triangle is looking a little bit different. Okay, a little bit different here, 8 and 12. Okay, so when we're looking at my sides, we always do the angle bisector as one proportion. Okay, we see that this is going to be x over 8, right? So we have x over 8. If we're using that side, we're going to make it proportional to 15 over 12, right? Angle bisector as one ratio, and then the other side as the other ratio, and then we just do our cross multiplication and solve for that. I believe x comes out to be 10 on that. X comes out to be 10 on that. So the key with that is putting those special segments as part of one ratio. Okay, as part of one ratio, and then matching up the other sides in your other ratio as well. Okay, other ratio as well. And we're going to look at page 504. Take a look at page 504, triangle angle bisector theorem. An angle bisector of a triangle also divides the side opposite the angle proportionally. Okay, so let's take a look at theorem 7.11. An angle bisector in a triangle separates the opposite side into two segments that are proportional to the lengths of the two other sides. Okay, to the two other sides. So we see, okay, JM is the angle bisector. Okay, JM is the angle bisector of JKL. Then we look KM. Okay, KM would be to LM. So we're basically looking at this side would be proportional. Okay, this side would be proportional to this other side. So if this was 6 and 3, okay, and this side is 15, this side would be what? Half of that, so 7.5. Okay, so that would be 7.5. All right, so take a look at example 3 on that, and that's where you're going to take a look at that, and you're going to be given a logarithm on that. You're going to be given a variable to have to solve for, and to find that side, we see that we, to find the length of ST, okay, find the length of ST, we take the total side. So if we take a look at this, okay, if we have a side of a triangle, okay, and the whole thing is 18, and this is X, this side is going to be 18 minus X. Okay, that's going to be 18 minus X. That's if you're given the total, right? Because if X equals 6, this would be 6, and obviously this would be 18 minus 6, which would 12. 12 plus 6 would be 18. Okay, so take a look at that in terms of finding the lengths of those sides. Now, another suggestion, write down, diagram the figures on the homework so that you can put in the values of those sides so that then you can make your proportions correctly. If you don't write down the triangles and fill them in, it's going to be much more difficult for you to get that homework. I'm available this afternoon and available tomorrow as well. So there you go with lesson 7.5, parts of similar triangles. Your assignment will be on Google Classroom. Have a good day.